This presentation is about serial dilutions. This is a part one of a series of, it's going to be serial dilutions explained, and then serial dilutions, the math, which will be me with a whiteboard going over serial dilutions and how to figure out the math between the dilutions and the ratios. Then part three will be a video of an actual serial dilution, performing one with test tubes and pipettes, etc. And then part four will be serial dilutions with titers. Okay, so this is part one, explaining serial dilutions. So serial dilutions are used for a lot of things in the lab. We use dilutions and serial dilutions for a lot. So you have a smear or you have a drop of blood and you're trying to count red cells, individual red cells, but you know how many red cells are in a drop of blood, and there are so many that you just can't count. So what you do is you perform a serial dilution in order to dilute the specimen enough that you can count the number of cells on the slide. A serial dilution is any dilution where the concentration decreases by the same quantity in each step, in each successive step. So again, you're diluting by a specific amount of solvent or diluent, and so it's serial because that means they're the same, and each time your original sample, whatever it is, your patient serum, your patient blood, gets less and less concentrated and more, quote, watered down, unquote, diluted. So when you perform serial dilutions in the lab, you have to know the dilution of each tube. You have to keep track of what the dilution is in each tube. So a chart is actually the best way to keep track of the dilutions of each tube, and in the next slide I'll show you kind of what I do. Once you know the dilution factor of what you need, so for example, if you know that you need to do a 1 to 2 dilution, once you have that original dilution of what you're going to have to dilute by, you got it made in the shade for the rest of the time. You just need to know what your original dilution factor is going to be, and that will be the same for the rest of your serial dilution because it's always the same. So you can either draw these or you can use your test tube papers that I think are in your packet. But what I do is I draw them out and I draw my test tubes, and then I draw how much is in each test tube. So in this test tube there's 1 milliliter of saline, so all of these have 1 milliliter of saline because this is a serial dilution, they're all the same. And then you're going to pipette 1 milliliter of serum into the first tube. You're going to mix it up. Then you're going to take a pipette and take 1 milliliter of this and put it into this one, and you shake this up, and you can see, so it's a 1 to 2 dilution, which means if you take this 1 and put it 1 over 2, it means that half of your solution is patient serum and the other half is saline. Okay, and then you just kind of keep going down the way and make sure you write down all your dilutions underneath each tube, so when you finally get to where your final answer is, you know what your dilution is in that tube. There are some times when you are analyzing a blood sample and the results that you get are above what your analyzer can actually do. So when this happens, whatever it is you're working on has to be diluted and retested, and then the result is multiplied by the dilution factor. So for example, you have a blood glucose of 800. According to the manufacturer of your instrument, the highest glucose result that can be valid on that instrument is 500. So you're above where your answer can be valid. So now you have to dilute the sample. So this serum was diluted with a 1 to 10 dilution and retested, and now you got your result with the dilution, which was 80. So your patient's glucose is not 80, right? You have to multiply your 80 times what your dilution was, which was 10. So now you know that the 10 by 80, which is your dilution, and 80 was what the result you got, is the actual value of the patient glucose. Sometimes if you try one dilution, it's not enough, and you have to continue on with serial dilutions. So if you performed a 1 to 2 dilution on another patient, and that 1 to 2 dilution was 700, that is still outside the linearity of and accuracy of your machine, right? So you still can't report out that 700 because it's above 500. So you'd have to do a serial dilution to get the glucose level down below the 500 that your analyzer can read accurately. So you'll do a 1 to 2 serial dilution, and at the dilution of 1 to 16, which is the fourth tube, your glucose value was 100, finally underneath 500. So if your dilution was 1 to 16, and at that 1 to 16 dilution your glucose value was 100, what is your reportable result? So you would take the 16 times the 100, because you have 16 dilution, times what the value was of the glucose at that dilution. You multiply them, and now you have a patient glucose of 1600, which means the patient is extremely ill or is no longer with us, because that's a very, very high glucose level. And a patient like that, their blood's probably like syrup. Okay, so ratios versus dilutions for serial dilutions. Ratios and dilutions are both written as either x to y with the colon in between them, or x over y as a fraction. So your ratio is the volume of the solvent over, or dot dot, over the volume of the diluent. So if you have a 1-to-1 ratio, it means you are putting in 1 volume of your patient specimen into 1 unit of your saline or whatever. Okay. The dilution now is the volume of your solute, which is the 1 milliliter that you're putting in, over the volume of the solvent, which is in the test tube already, like the saline, plus the volume of diluent you're putting in. Oh, I'm sorry. This is actually solute and not solvent. So cross that off if you printed this out. This is actually solute. So it's the volume of the solute that you're putting in already, which is the 1 milliliter of your patient specimen, plus the volume of the diluent, which is the saline that's already in the bottom of your tube. So your dilution would be 1 to 2. So you have what? You pipette 1 milliliter of patient serum, which is the solute, into 1 milliliter of saline, which is the diluent or the solvent. Your ratio, which is the amount of serum you're putting into the test tube to the amount of saline that's already in the test tube, is 1-to-1. So the ratio basically is the physical, how much of this solute, how much of my patient sample or other concentrated stuff, liquid, do I need to put into how much saline or water or whatever to dilute it to get it to where I want to be. So your ratio is more like what you're putting in to what's already in there. Your dilution is the amount of serum you're putting in, your amount of your solute, over or to the amount of serum that you're putting in the test tube, the amount of your solute, plus the amount of your diluent or solvent. So your dilution would be, if you have 1 milliliter of patient serum into 1 milliliter of saline, your dilution would be 1, right, because you're putting 1 in, over, you have 1 plus 1, which would be 2. And this dilution is telling you that if you do the 1 over 2, figure it's like 1 over 2 is a half, which means half of what you have in that tube right now is your patient serum, and half is saline. And I will go way further into this in the next video. So if you don't quite get it, it's not a problem. Next video, I'm going to draw it all out on the board and go over a couple with you. Okay. So, but just so you know, a 1 to 2 dilution may be called a double dilution or a doubling dilution in your lab. So when you get to clinicals or you get to your lab and somebody says, I want to do a double dilution, it's a 1 to 2 dilution. That's just so you know. And I kind of want to go over this dilution again. So if you have a 1 to 10 dilution, that means 1/10 of that mixture is serum, 9/10 of that mixture is saline. If you have a 1 to 5 dilution, that means 1 unit or 1 milliliter, 1/5 of that mixture is your patient serum, and 4/5 of that in your tube is going to be the saline. So kind of keep that in mind. Okay, so I'm done with this, and the next one will be us actually drawing out the serial dilutions on the board. Okay, all right, thanks you guys.